Good day, everyone. We are to present our solution to our hotel business client. Introducing BOOCA. It's a machine learning solution to deal with booking cancellations for our client, Hotel Lita. So this is an Eskwelabs capstone project. To give you a background, hotel revenue management is the application of information systems and pricing strategies to allocate the right capacity to the right customer at the right price and at the right time. In order to do that, hotels introduced advanced bookings. This contract gives the customer the right to use the service in the future at a settled price, usually with an option to cancel the contract prior to the service provision. So this technology helps hotels to forecast the revenue and performance. It also provides satisfaction for the customers in search of best deals while locking in the room availability in advance. However, when the customer cancels the booking or does not show up, it will be an opportunity lost for the hotel. So for your information, according to studies, there is 20 to 60% cancellations from total bookings. And if not considered, it will translate to 20% income loss. So in order to amend this, hotels manage risk by implementing overbooking and cancellation policies. But this will reduce the number of bookings and may cause terrible customer experience. Another solution is to avoid cancellation. When determined, they can take proactive actions like giving promos or not allow free cancellations for the customers. Lastly, the hotel can just cancel the booking. So our client, Hotel Lita, is not exempted from this issue. So the client needs an approach for booking cancellations to answer the following questions. Number one, which booking will likely cancel? Number two, what could be the reasons? And lastly, how to approach the cancellation. So our proposal for our client is BOOCA. It's a serious technological framework grounded in booking cancellation prediction model. So it predicts the probability of each booking to be canceled. This will help our client to produce better forecasts and reduce uncertainty in management decisions. It can also help them in revenue management, such as inventory allocation, pricing decision, and other management contexts. And it will enable our client to act upon those specific bookings. And of course, to help them in developing their booking and cancellation policies. So our solutions objectives are to build a model to classify bookings with high cancellation probability, to determine if the global prediction model can be used for a specific hotel, and lastly, to identify which features in hotel databases contribute to predict a booking cancellation.
So here is our dataset. For data information, the data contains 30 hotels worldwide with dates from 2019 until the first half of 2022. The data contains 1.8 million rows and 28 columns. For the hotel category, there are different hotel categories such as luxury, upscale, mid-scale, and economy. This is an example of a mid-scale or economy hotel, while this is an example of a luxury hotel. Hotels have different room types. These are often categorized into groups, for example, groups 1 to 3. This deluxe room is an example of a lower class of room type. Here's an example of a higher class room. Usually, suites are categorized as the highest room class for the hotel. For our dataset terminology, we have booking date. It's the date when the hotel reservation was booked. Lead time, it's the number of days between booking date and check-in date. Sell channel, it's where the reservation was sold, particularly direct, hotel, or GDS. Length of stay, it's the number of days a guest will stay.
For our exploratory data analysis, we first check why hotel cancellation is a concern for our client. Now, based on the data set that we have, 21 out of every 100 hotel bookings are being canceled. This is also an indication that the data set used is highly imbalanced. Knowing that a global pandemic has affected every sector across the globe and the hotel industry is among the hardest hit, we also checked our data and how the pandemic affected hotel cancellations. In here, we can see that hotel cancellation rate is highest during the pandemic, which is equivalent to 27%. Checking the rooms sold per month, we can see that there was a drastic decline in April 2020, which is caused by COVID. COVID has overwhelmingly impacted the sales of luxury hotels by 65%, while less impact is observed for upper mid-scale and upscale hotels. Exploring the data more, we did a relationship check between the quantitative variables used in the study and the target variable, which is cancellation indicator. The top two associated variables to cancellation are lead time and number of changes. And here we can see that lead time has weak positive correlation to cancellation, meaning the longer the lead time, the higher the chance of booking being canceled. Also, number of changes has weak negative association to cancellation, meaning to say the fewer changes in the booking details, the higher the chance of being canceled. So based on the correlation check that we did, we took the average lead time of canceled bookings. It goes to show that customers tend to cancel their bookings 10 days before the arrival date. Interestingly, customers who canceled their bookings made low changes in their booking details. Now, we also checked how changes in booking details relate to lead time. We found out that they are negatively correlated, meaning the longer the lead time, the less change are being made by the customer or vice versa. Canceled bookings are hotels with higher average daily rate. Average daily rate is the best indicator for hotel room rate quality. ADR is computed as total rooms revenue divided by total occupied rooms. Now, customers who book for luxury hotels tend to cancel more compared to those who book for upper mid-scale and upscale hotels. Pre-modeling, we also did a quick correlation test between the quantitative variables used in the study. It goes to show that some variables are highly correlated. Those are booking date year and stay year, and booking date month and stay month. And here we can see that customers book a hotel during the same month of their stay.
Here is our machine learning model. For methodology, data was prepared and analyzed. We determined that the 2020 data has outlier-like behaviors compared to other years, so it was removed. Each model was tested using stratified k-fold. The global model and local models were compared using their predictions on each hotel. SHAP analysis was later used to determine the most important features. For choosing the best model to use, we have recall and precision. CatBoost has the best precision and recall among all models. We have train accuracy and train F1 score. CatBoost also had one of the best F1 scores. Since this model will be used later on to determine if the hotel is pricing correctly, we want a balance between precision and recall. And since our data is imbalanced, F1 score was used as the main metric. We also considered balance accuracy. Lastly, CatBoost has one of the best runtimes among all the models. For resampling, all KNN had comparable F1 score with other resampling methods while having 4 times faster runtime than other methods. The same process was used in choosing the best local models for each hotel. All KNN and CatBoost was chosen because of its good F1 score and fast runtime. The local and global models had varying performance across hotels. There is no one model fits all for all hotels. Choosing between global and local models would produce better results. Among the created models, we decided that the model that the hotel will choose will be the one with the highest F1 accuracy.
Okay, so after running our models, we were able to determine the important features that affects the prediction. Here, we compare the results from the global model and 2 local hotel models. Notice that there is a different story for every model because their important features are not the same for all. However, there are 3 common features present to all, and these are the number of changes in the booking, wherein the lower changes leads to cancellation, lead time, where the higher lead time leads to cancellation, and average daily rate. For the global model, higher cost of ADR may lead to cancellation, but this could not be the same for all hotels. Okay, so let's do a cancellation booking analysis. For the first example, the lead time is long. It has a low-class room type for $219.8. Intuitively, the customer must have been planning and found a better deal, thus the change of mind. So our recommendation is that the hotel should review their policies with regards to lead time in bookings and revisit their pricing analysis with respect to room types. Another example, here the customer access through mobile, the number of change is low and the booking was recently made and there is no lead time. So intuitively, this booking could have been an error booking from the customer, thus canceled. For our recommendation, we encourage the hotel to encourage their customers to add reasons for cancellation. So in all, BOOCA delivers. Our model was built to classify bookings with high cancellation probability, and our criteria to determine if the global prediction model can be used for a specific hotel is efficient. And the features that contribute to predict a booking cancellation probability were identified. This will help Hotel Lita's business whenever there's a booking cancellation. So for our conclusion and recommendations, there is no one model fits all for all hotels. Choosing between global and local models would produce better results. And this can be measured through our pipeline. And another recommendation is to include consumer data, such as proximity of the consumer, in the training model to improve the results. So that ends our capstone. Good evening.